Hi guys, hope all of us are doing fine. My name is Ernest and I'd like to welcome each and every one of us to our discussion for today. Now in this case, I'm going to look at a concept of one type of forces. And this is one of the forces, type of forces which we described in our last discussion on the different categories of contact forces. Now this force goes by the name friction. And we're going to see that by definition, basically, the concept of a friction refers to a force that always acts to resist the concept of a motion. And of course, this is going to be the case for an object that is sliding on top of another one. So in this case, we're going to see that as we have defined this one, basically, friction is going to be a force. And this force is going to always act, a force that always acts to resist motion. And of course, we have said that this is going to be motion of an object that is going to slide on top of another one. An object sliding on the surface of another. So this can form just a summary statement on what basically the concept of a friction refers to, which I've said is a force which always acts to resist motion of an object sliding on the surface of another. So in this case, we can just give an illustration of this simple definition which we have given for the concept of one of the contact forces referred to as friction. So suppose we have two items shown as such. We're going to see that if we try to look at the surface of this specific item, these surfaces are going to be in contact with one another. But if we try to move one surface against the other one, then therefore we're going to see that there's going to be some kind of a resistance which is going to be developed. And this is going to be the concept of friction, which we are going to see then being realized between the two surfaces of A and B. So if we try to look at this specific aspect of friction quantitatively, we can have this particular set of, or rather a block which is resting on a surface. And therefore, from our previous discussion, we said that if an object is going to rest on a surface, it's going to be experiencing some kind of oppositely directed but equal forces. Now, in this case, we're going to have a weight and a normal force acting in the opposite direction given as such. So according to Newton's third law of motion, we're going to have these two specific forces which are going to be equal. And if we, of course, say that this specific of course, block is going to be resting on a surface. If a force is applied in this particular direction, which we can give in terms of a t, if this is applied in that specific direction, we're going to have different scenarios which we can give, or perhaps for this specific force which has been applied, whereby we're going to see that at a specific point, we're going to have this specific force given in terms of F, which is going to be greater than 0. So long as this force has been applied to a particular quantity, we're going to see that it's going to be greater than 0. And then we can have this force, which is of course still smaller than this specific aspect of this particular force which we're going to regard. So in this case, I'm going to regard to this specific quantity as friction, and therefore friction is going to ensure that this specific force is going to be maintained, this specific object is going to be maintained on this surface until it has been overcome to enable the concept of sliding to take place. So in this case, whenever this specific force has been applied, and of course the object is still, this is the case of application of a small force, then we can conclude that this specific aspect of friction is greater than 0. And then we're going to see that the force which has been applied is relatively smaller compared to the friction if this specific object has not moved. And of course, we can as well conclude that the friction is equivalent to this specific force which has been applied. And in that case, we're going to assume to see that in all the instances for the three options, this specific object is going to be still static, whereby some of the force or a small force has been applied in that specific direction. So we can look at another scenario for this specific case, whereby we're going to have a slightly a large amount of force has been applied. Now, in this case, we're going to monitor and try to see what is the effect which we're going to achieve. And in this particular case, we're going to see that this specific force which is trying to resist the motion, we're going to refer to it as a static friction. The concept of a static in a sense that it is going to be an object which is still at rest and not in motion. So this is referred to as static friction, which is going to be causing this specific object not to move. And therefore, we are going to experience, for the first case, the effect of a static friction affecting this specific object in that case. And for the second case, we're going to apply relatively a larger amount compared to the first force for T which was applied. And in this case, we're going to see that this specific aspect of static friction increases until it acquires a maximum value before the block starts sliding. And in this case, it's going to be this specific aspect of a static friction. So in a sense, we're going to see that this T is going to be increased to a specific amount whereby we're going to have it overcoming this specific equilibrium whereby the block is going to start moving. And in this case, we're going to have this one basically relatively greater than this static friction which we have seen. And this is the case whereby we'll be having this particular, of course, a block moving towards that specified direction. And in a sense, this is going to be giving us some of the characteristics or properties of this particular kind of static friction, which we are going to, of course, perhaps list in a summary form and try to see what are its properties as I've just said. So one of the properties of this static friction, as we're going to see, is that the mass which is going to be involved, of course, for this static friction, or this static friction which is going to be involved, of course, is going to be given as a static friction maximum. And at the static friction maximum for the second case, which I've said, the object will start sliding in that case. So we're going to have this static friction shown using this F sub S maximum. And therefore, this is going to be independent of the contact area, independent of the contact. So in this case, the contact area is the region between, the area of contact between the two objects, the one which are sliding against one another, one sliding on the surface of the other. And then we're going to see that property number 2 for this static friction is that for a given pair of surfaces, maximum static friction is proportional to this specific aspect of a normal. So we can give that one in a summary form that for a pair of surfaces, or a pair of surfaces, we're going to have this specific aspect of the maximum static friction, of course, proportional to this specific aspect of a normal. So I've just given a normal force applied in this different direction equivalent to weight according to Newton's third law of motion. So for the second case, we're going to see this specific property coming into play. And of course, we're going to look at another one which is going to be giving us this specific. So from the second property, we can develop a relationship of static maximum friction. Static friction maximum is equivalent to, of course, we can have that mu, and then we have n, where mu is equivalent to the coefficient of static friction given using that specific notation. So in this case, this is going to be giving us one of the relationship from the second property. And of course, we can look at the third property of this static friction and of course try to see what some of the properties which we are going to see. Of course, in this case, we are going to see that this specific aspect of mu, which is a coefficient of static friction, is going to depend on the nature of the two surfaces which we have said. So therefore, we are going to look at other specific, perhaps specific surfaces which are going to be affected and try to see how this, of course, a coefficient of static friction is dependent on those surfaces. Now, in some of our discussion on the concept of support and movement of the body, basically on the concepts of human anatomy, I've talked about the concept of synovial fluid. And synovial fluid is the fluid which is found in between the bones, and its main function is to reduce friction during movement. And in this case, we can give the coefficients of static friction for this one equivalent to 0.003. And of course, that is just a notation from this specific point in order to just, of course, give one of the applications of this specific idea which I've just mentioned. So in this case, we can look at another property of this, of course, static maximum static friction, which is property number 3, of course, which we are going to look at. So in this case, we're going to see that for this object to move, the forces which are going to be constant, of course, are going to be relatively smaller than the forces required to start this specific motion. So in a sense, this refers to the concept of sliding, whereby the force which is going to be involved in sliding this specific object, force involved in sliding the object is relatively smaller than this static friction maximum given as that one. So that's going to be another property which we are going to come across. And of course, we're going to see that that's for the sliding or this specific friction. Then therefore, we're going to have another terminology for this kind of a force involved during sliding, which is going to be relatively compared to this specific one. So this case, this is the force which I've mentioned, that the force involved in sliding the object is relatively smaller than a maximum static friction force. And of course, we can introduce this aspect of a force which we are going to refer to as kinetic friction or sliding or kinetic friction, which can be given in terms of F sub K. So in this case, this sliding or kinetic friction can be given in this specific sense, and we have said that this force is relatively smaller than, of course, this specific static maximum, of course, frictional force which we have given in terms of this specific representation. So this static kinetic friction which I've given in this case is independent of the contact area, and of course it's going to be just like this one, proportional to the normal. So we can just give a representation of this sliding or kinetic friction in terms of F sub K is equivalent to mu, and then we're going to have N. And in this case, this mu is going to be the coefficient of, so the first one we had given is a mu S, which is a coefficient of a static friction. But if we try to change this specific notation, we're going to have this one given in terms of a mu K, which is the coefficient of this sliding or kinetic friction, given in this specific so this is going to be kinetic or sliding friction given in terms of this specific notation. So in case we come across the two, then therefore it should be appropriate for us to differentiate between the two. So in this particular case, we are going to see that this is determined by the nature of the two surfaces which I have just mentioned, and it's nearly independent of the concept of a velocity of this specific object which is moving on the surface of another. So in this case, we come across these three specific aspects of the properties of these two kinds of frictions, then therefore we can be able to differentiate them. Now in our next video, I'm going to be giving some of the examples in terms of evaluations which we're going to work on, and try to apply these two formula which we have given for kinetic friction and the static friction in those two respective forms, as I've just said. So kindly check our description boxes for various links of other videos. Engage us in the comment section, and also ring that notification bell for an update on various uploads we do in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.